Alrighty. This is going on page 72 when we are done. We are revisiting particle motion. We did particle motion last semester with just derivatives. Position, velocity, acceleration, right? Okay. We are going, so when we took the derivatives, we go this way, and this is where you go you take the derivative with respect to time, right? And if you're going this way, this is where we integrate with respect to time, okay? PVA stands for what? Position, velocity, and acceleration. That would be PDA, not PVA if it was V. Position, velocity, acceleration. So remember, position could be S of t or x of t, either way. Velocity is v of t for velocity, or it could be s prime or x prime, either one, because velocity is the derivative of position. It's also the rate of change of position, right? And then speed is the absolute value of velocity. So speed and velocity are not the exact same thing. Velocity gives you direction and gives you distance and direction. Acceleration, a of t, or it's the derivative of the velocity, or it's the second derivative of position. Okay? We all okay with that? That sound familiar? PVA in that order. All right. So the way we want to think about velocity, this is the rate of change of position. Cool. And acceleration is the rate of change of velocity. Hence the being the derivatives of them, right? So we can do instantaneous, and we can look at average velocity and average acceleration. When we do that, when you have average velocity, your numerator here, this is the change in position, right? That's what delta means, change in position, right? Over what would B and A represent? The change in what? What's your input? Time. Change in time. Right? So when you're going to find velocity, it's the change in position over the change in time when we're looking at slope, right? So remember we were doing average velocity, average, and we were doing this last week. We did integral from A to B, but out front we multiplied by 1 over B minus A, right? Because it was the average. So if I want the average velocity and I'm using the position, that's what I'm putting in there. Or if I have the velocity, I integrate velocity and multiply it by 1 over B minus A. That's your average that we were doing before. So average velocity, either you were literally substituting in position to figure out your average velocity, or you were integrating velocity and finding the average by multiplying that by that fraction out front. Does that make sense? So with acceleration, you have the change in velocity over the change in time, or you integrate acceleration and multiply it by 1 over B minus A. Because again, that gives you your average that we were looking at last week. Does that sound familiar? I'll take that as a yes. Okay. Then we have displacement and distance. Okay? Displacement and distance. What's the difference between these two after the integral? What's absolute value, right? So if I have this, and I'm going to say that this is my velocity, this is my time, right? And well, let me make my graph better here. Say it looks like this. When your velocity is positive, which direction is your particle moving? To the right or up, either one. And if your velocity is negative, it's moving to the left or down, right? And so when we're talking about, for this right here, if I move this far to the right and then this far to the left, those are kind of knock each. If I move to the right and then I move to the left and it's the same amount, then I end up right back where I was, right? Let's say I went 5 feet. And then I went 5 feet this way. Go 5 feet there, 5 feet back. I'm in the exact same spot, right? So my displacement would be 0. Displacement would be 0. If, though, I went to the right 5 and then I did that and I took the absolute value, made that 5, right? So instead of this being negative, it's now positive. So if I move to the right 5 and then back to the left 5, I actually moved 10, I walked 10 feet. Like I get credit for that on my watch, right? That's how many steps I took, even though I didn't really go anywhere because I'm back in the same spot. That's your difference between displacement and total distance. Okay, make sense? And that's why the absolute value just makes it all positive and you get all that right there. Okay? Then remember the fundamental theorem of calculus. If I integrate velocity from A to B, v of t dt. Okay? This is an accumulation. Okay? So when I integrate my velocity, I go from velocity to how much position, because if I'm here and I'm going this way, okay, it's how much did my position change? So this would actually be S of B minus S of A. Right? That's the way the fundamental theorem of calculus works. And that's where we get these two right here. This is where I'm starting. This is where I'm ending. So it's the final position minus my initial position gives me how much I actually moved, which is what that is. So if you're just looking for one of them, you can start by just setting it up this way. Or if you want to make sure you get your subtraction in the right place, you can set it up like what I wrote in red and then figure it out. If I want to know my final position, I take my initial position plus how much I changed. If I want my initial position, I take my final position and subtract how much I changed. Okay? It's addition if this matches the bottom. It's subtraction if this matches the top. However it works for you to remember it, whether you just remember how to set it up or you set it up like this over here to begin with so that you can make sure you get your signs in there correctly. Okay? We okay with all that? All right. And by the way, what we were going to do today, I changed what we were going to do today. We were going to had cut up questions. We were going to work on the board, but it was going to take us a couple of days. But we're a couple days behind, so we're just going to kind of work through these together. So, particle moves to the right or up because v of t is greater than 0. These are our justifications. We're writing stuff out. Particle moves to the left or down. V of t is less than 0 or negative. So this means positive. This means negative. Okay, and then again, because this is all stuff that we've already talked about. Speeding up, so our speed is increasing. V of t and A of t have the same sign. And you have to specify if they're both positive or both negative. You can't just say same or different. You have to specifically say what the sign is. If it's slowing down, speed is decreasing. V of t and A of t have opposite signs. All that sound familiar? Yes, Ms. Finnan, that sounds familiar. This is going to be great. You know, I've made it this far. We can do this. All right, flip it over. All right, for t being between 0 and 6, particle is moving along the x-axis. That means we're going left and right? That's how we know that for sure. Our position, we're using x of t. It's not explicitly given. We don't know exactly where it is. We do have the velocity function, and we have the acceleration function. And we know that x of 0 equals 2. If they give me something, I'm probably going to need it at some point. So then it says, is the speed of the particle increasing or decreasing? If I'm looking for the speed of the particle, what do I need to know? How do you know if it's speeding up or if it's increasing or decreasing the speed? Acceleration and what? Velocity. So I need to find the sign of both, right? So That means for this, I need the sine of v of t and a of t. That's what I have to find. Okay, so when we go back down here to do a, this is a calculator question, so we're going to go put these in our calculator, which means we want to add a graph. So if you turn it on and you're on the black screen, 1 for new, and then say no if it asks you want to save it. And then 2 for graphs. And in F1, we're going to put the velocity. So that'll be 2. And then right here to get sine, see where it says trig next to 7? You hit trig. You get sine. It opens the parentheses for you. E to the, and you cannot use t, don't forget that. E to the x divided by 4. And then plus what? We good with that? And then I'm going to hit enter. Okay, so when I hit enter, I didn't put in my acceleration, which I wanted to do. So how do I get back to where I can enter a graph? Do you remember? Tab, because it seems kind of random. Tab. So then in F2, I'm going to put 1/2. And remember, if you want to get the fraction, it's control divide. 1/2, oh, that's a 0. 1/2 times e times t to the 4th. Oh my gosh, undo my control. What just happened? Did I delete everything out? Oh my God. Okay. All right, let me do this again. 2 times the sine. If y'all don't have this done by the time I get done, it's going to be sad. Times e to the x divided by 4 plus 1. You can also just arrow down and then F2. Oh my gosh, this board. Part of it's me being a moron, but part of it's a stupid board too. Okay. Then e, and the exponent is x divided by 4, not minus 4, divided by 4 times trig cosine of e to the x divided by 4 power, and then I'm done. Whew, hopefully. Is that what yours looks like? Yeah? Okay. Now, I don't really care about the graph. Okay? I need it in there, but I don't care what it looks like, I guess, is what I'm saying. Just make sure ours match at this point. All I really need to know is at t equals 5.5, what is the sign of velocity and acceleration? So I'm going to add a calculator. Control doc to add a page. I'm adding a calculator. Now, and we're also going to go back up here and write ourselves a little note here. In v of t, we put that in f1 of x. A of t, we put that in f2. Okay? That way you can keep them straight. Do you have to write that down? Do you get points? No, but like it's not a bad idea for yourself. So what I want is I want B of 5.5, and I want A of 5.5. We put these in the graph so that the calculator could do a lot of stuff for us. So there's times where we're going to type them into the graph, but we really don't care what the graph looks like. So when I'm here, and I can type, there's a few different ways you can get your F1 up here. I think it's just easiest to type it. F1 of 5.5. And I also need F2 of 5.5, and then it just does it all for me. Okay, everybody with me? It's been a while since we used the calculator, so holler at me if I lose you somewhere, if you don't know what I said, or whatever. What happened there? Is it not what you have? And mine's a 0. Oh, you got what y'all got? That means I messed up somewhere. Oh, you got what I got. Okay. So it's them. Okay, I'm just kidding. Now let's go back and look at our graphs. So if I want to go back and look at my graph, the way you turn your pages are these arrows right here. So I'm going to hit Control and then to the left. Now I see my graph. So look at your F1. Is that what you have typed in? Say that again. These are both a straight line because why is it a straight line? Something is weird with your graph. Hit menu. And 3 and 1. And it's still that. Okay, arrow up. Let me see it again. Yeah, why is yours like that? 2 times the sine of e. Did you get the same thing on the other screen? Mm-hmm. See, you have this slider, and I don't know why. Yeah. Let me have this calculator and go get a different one, because I've had trouble figuring out how to get that slider off before. I don't know, and I think the people that do it, they don't even know how they're getting it there. I don't either. I'll have to figure that one out. Maybe it's the 2. Oh, no. I figured it out, I think. Well, bring it just in case I'm wrong. Clean geometry, 3D graphing. It's in geometry mode for some reason, and I don't know how to get it off of there. So, yeah. Okay. Did the rest of us figure this out at this point? Did y'all figure out what was wrong? Yes. Okay. Got it. Okay. So what we have found, and this is what we need to write down. Okay. This is a calculator question, but we're going to write down negative 0.45337. And then negative 1.3585. Now, I would say just write down 4 decimal places. I know I wrote down 5 on the first one, but that's because what I already wrote on my piece of paper. I'm not really sure why. So knowing this, let's answer the question for A. Is the speed of the particle increasing or decreasing? Increasing. Why? Because the signs are the same. The signs are the same, therefore the speed is increasing, right? So negative velocity, that just means we're going to the left. Okay? So I would say then that the speed of the particle is increasing at, okay, I have to have my time, at t equals 5.5. Do we have units on here? We do not. So at t equals 5.5, because v of 5.5 and a of 5.5 are both negative. Or you could say v of 5.5 is less than 0 and a of 5.5 is less than 0. I mean, that would be okay too, but. Oh, yeah, I'm sorry. No, I'm sorry. Show up late, no paper. Grab a calculator so that you have that too. Alrighty. Everybody okay with that? Yes? All right, so let's look at B. B says, I want the average velocity. Average velocity. So average velocity is the change in position over the change in time, right? So if I had the position function, I could substitute in 0 and 6 and figure out what that is and do the slope, but I don't have that. Since I don't have that, to find the average velocity, I'm going to do that 1 over b minus a times the integral from a to b of v of t dt. Average velocity, okay? So over here, I'm just writing like what we're finding, and then we'll actually do it down there. And we're going from 0 to 6. So what I want here on B, that means I'm going to go 1 over 6 minus 0 times the integral from 0 to 6 of v of t dt. Okay? Everybody okay with that? So we got to know how to write it, how to set it up. But the good news is it's a calculator question. It's going to do all that work for us. We don't have to do the integrals by hand. So when I go to put this in the calculator, do I already have v of t in the calculator somewhere? Yes. Where is it? F. It's in F1, right? Okay. Then this is using t's. We're writing down t's because we have to write our answer down correctly, but in the computer. In the calculator, we're doing x's. All right, so I'm going to go back to my calculator screen. Control, right arrow. And the first thing I do is 1 over 6 minus 0. I'm just going to put 1 over 6. 1 over 6. I'm just trying to move my cursor there. Okay, 1 over 6. We got that? And then we want to multiply it by the integral, right? So there's a couple different ways to get there. You can get there from this little key right next to the 9, but that is also kind of hard to see sometimes. So another way to get there is menu. What class are we in? Calculus. Good job. We knew the answer to that one. 4. And what are we trying to do here? An integral, right? Number 2. And then this pops up. And we are going from 0 to 6. And then this is f1 of x. And then we have to put dx. I do menu. We're in calculus. And I want the numerical integral, which is 2. Menu. We're in calculus. That's 4. 2 for numerical integral. The other way to do it, I'll just show you. You can hit this little key here, and then you can look at these little tiny things, and then you can find that one. You can select that one. That works too. But that's up to you. Okay? Everybody got this okay? We're good? Okay. And then I just hit enter, and there you go. That's it. This would equal 1.949? So it's velocity. Let's pretend like t is in minutes, and the distance is in feet. Okay, can we do feet and minutes just because it's bothering me that there's no units, and I want to make sure you know how that works. So this would just be, since it's velocity, average velocity, this would be feet per minute. Okay. Yeah, let me know if you're having calculator issues. Oh my goodness. It says it's not defined. Yeah, you have no F1. You have no F2 or 3 or 4 or 5. You're just a hot mess. Okay, yeah. Yeah, if you delete it out of there, it's gone, dude, because that's why we typed it in. It doesn't remember it forever. I'm sorry, you can't delete it. Okay. Anything else on B? We all good on B? Okay. C, let's see what C says. C says find the total distance traveled by the particle from 0 to 6. Okay? Now, remember, if I integrate velocity, I get position, right? But when I integrated it and then I divided, that's why I got the average velocity. If I want the total distance, I integrate velocity to get distance. So I'm going to go from 0 to 6, v of t dt. But does this get me the total distance? What does that get me? Just written like that. Displacement. That's if I walk to the right 5 feet and I walk to the left 5 feet. This would integrate to give me 0, right? We want the total distance. I want that 10 feet, which means I need it to all be positive, so I need the absolute value of this. Okay, we good on that? All right, so we're going to go back over here to the calculator. And this time, let's go ahead and do it from this little key here. You can do it however you want, but it's this, and if you can tell, I don't know how, to me it's a whole lot smaller on that calculator, but you can get it right there. And if the wrong thing pops up, you know it's the wrong thing, right? So I'm going from 0 to 6, but I need the absolute value, right? So got a couple of things. It is right there under this key. If I hit that again, you see right above where we got this. Boom. Boom. Absolute value. This little key next to 9 where it gives you all this mess. Because you see, you can also get a square root here and some other things, which I would not get it from there, but you can get it from here. You can also get it from the menu, I believe. Yeah, menu. I think it's number. Oh, maybe not. I forget where it is here because I do it the other way. But then right here, this is where we put F1 of, you have to open your parentheses, of X, and then DX. Boom. So this is 12.573 what? What would the units be here? Is it feet per minute? It is feet. When you integrate velocity, you get distance or position, basically. So that's where the feet comes from. This minute right here comes from dividing by that. So when I integrate velocity, I get position, or in this case, total distance. We okay on that? Yes? All right. D. D says for t being between 0 and 6, the particle changes direction exactly once. Find the position of the particle at that time. Okay, it changes position exactly once. How would we figure this out? Any ideas? Say that again. Say that again. Find the zeros for the velocity graph. Does that sound good? Why would that help me? Uh-huh. Okay. So remember your fun chart? So yes. I totally understand what you're saying and just want to explain it in a different way. Okay? So if your position... Wait, no, go ahead. No. What? Huh? I want my velocity. I want the velocity to be 0. That's what I'm looking for. Yeah. Okay. So how do we find that? Go to the graph. Okay. Go to the graph. Which one is velocity? Oh my God. Why won't this? Okay. F1. So if you're not sure when you're looking at this which one F1 is, because you can click on them, and this tells you it's F1, that's F2, or you could see what color they were, right? But it says it changes direction exactly once. And I have a few zeros here. From 0 to 6. Good. So do I have to find them all? No. I only really need this first one because look, 1, 2, 3, 4, 5, 6. Here's where it is, right there. Okay? So can we find that 0? How do we do that? Menu. Let me give you a little hint here. Because we can do it with both of these graphs being on here, but it would make it easier if I wasn't looking at the red one. So if I hit tab and I go up, and I go up, then I can click off of this, and then I only see the blue one. Otherwise, it makes you choose a graph, and it's doable. It's just not fun. Okay? So then, there we go. So we're going to find the 0. Menu, 6 for analyze graph. What am I looking for? 0. Okay, so I need to arrow over. I need to be to the left of that first 0. Hit enter or hit that middle button, and then right here, and I hit that. Okay, so I've got this 5 point something, 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 right? All right. Let's save this. Remember how to save something? Okay, so you're going to put the hand over it. You don't have to grab or anything. You just put the little hand, looks like he wants to grab it. Okay? And hit variable, which is right above 9. We're going to store the variable. Let's store this in B. I'll tell you why in just a minute. And then hit enter. And it becomes bold when you have it stored. Okay? Okay with that? All right, so is my answer 5.19552? What does that represent? Does that represent acceleration, velocity, position, time? What is it? Is that an x value or a y value? X value. The x value on velocity represents what? What is the x value or the input of velocity? What is this? What is that letter? T. It's time. So what we have is we have t equals 5 point something, something, something. And we put it in B. So we're going to put a little t sub B on there. Well, that's great. So I know what time it changes position. I want to know where it changes position, but I don't have a position graph, right? But remember, they told us this up here. See this right here? X of 0 equals 2. X of 0 equals 2. I know that if I integrate velocity, I get position. But I'm not going to integrate that thing by hand. But if I do integrate my velocity from 0 to B, right? Whatever that 5 is, that's what this is right here. If I integrate velocity, how can I make this part of things? The distance I have traveled is my final position minus my initial position, right? Do I know my initial position? It's this right here. I want my final position. When I integrate velocity, this is my final position minus my initial position. It is the fundamental theorem of calculus. And remember, if you are stuck on something, that might be it. Because almost always, that's what it's, when I look at this, I go, I know how to do this. I know this is not that hard. And figuring out what to do, and then it's fundamental theorem of calculus. So now, can we substitute some stuff in? Right? I know what this is what I'm actually looking for. What is the position at that time, right? So remember, it is the initial position plus the change in position that gives me that final position that I'm looking for. This is what I need to know. I know this one. What is this? 2. So in my calculator, I can put this in there, and it will spit out my answer for me. So in my calculator, I'm going to go back to my calculate screen, and I'm going to say 2 plus, and then you get your integral however you want. I'm going to do it that way. I'm going from 0 to whatever I stored that other thing at. If you forgot where you stored it, you can just go punch in a B. We called it B. At least I did. I don't know what you called it. But put B there because I'm not typing in 5 point whatever. And then what am I integrating on my calculator? F1 of x dx. That's my position. Okay, so my position at that time is 14.134. What would my units be there? Feet, because it's a position. Nope, you don't have to. You can just truncate. My suggestion to you is don't round, because you can round or you can truncate, and no matter how smart you are, some of y'all do some weird, wrong things with the rounding. So we're just cutting it off, okay? Because that's acceptable. Up until calculus, everybody makes you round because it's a skill you need. On the multiple choice questions, chances are pretty good they're rounded. And you still do need to know how to do it. I wouldn't risk it on these. I'd just chop it off. Okay? We good on that? All right. I'm going to go ahead and give you page 2, and we're going to get started on it. We're going to start on the side that says, with the chart, the no calculator, 2006. Okay. Oh, and we skipped that one. And I know sometimes you're like, 2006, these are so old. But they only actually release a certain number of them. But you can trust me when I say there are questions very similar to this that have been on there since 2006. It's just, we don't have permission to use a ton of their actual questions. Okay. Rocket A has a positive velocity, v of t. So positive velocity after being launched upwards, so now we're going up and down, from an initial height of 0 feet at time t equals 0. Okay? So the initial height, so basically x of, or do they use s, or I don't know. I don't know if they're using x or s yet. But x of 0 equals 0. Like that, they're not telling me this here because this is velocity. The velocity of the rocket is recorded for selective values of t over the intervals, as shown above. I want to find the average acceleration. Average acceleration. So acceleration is the rate of change of velocity. So that is the change in the velocity over the change in time, right? I don't have an acceleration function to integrate. If I did, I could integrate the acceleration function and multiply it by 1 over 80, but that's not what I have. Here, I am actually doing the slope stuff, okay, because of the information that I have. Does that make sense to you? Okay, and we're going from 0 to 80. So I'm going to, on A here, make sure I'm looking at the right one. We are doing, so the acceleration is approximately, we're going to do v of, what are the numbers, 80 minus v of 0 over 80 minus 0. And listen very carefully to me when I say this, is that acceleration is the rate of change of velocity, so it's not acceleration in there, and you have to show a difference quotient in your work. Like, I have to show that I have subtracted this stuff. Even though it's slope and it's easy, you can do it all in your head, nobody cares, right? It just really doesn't matter. So you have to show subtraction in the numerator, subtraction in the denominator. Then you move on if you want to skip steps, whatever. Okay, so what is v of 80? 49. Minus v of 0 is 5 over 80. And then, really, I can leave it like that. I mean, maybe we could go farther, but, and maybe if I needed to use it for another question, I might go back and simplify it. But that's it. I need units. So what are the units on velocity? Feet per second, right? And that is the numerator because that's velocity. The denominator is time, so that is seconds. You can write feet per second squared if you want to, but you can also just plop them in there just like that. And don't overthink things. Don't make it complicated just because you can. We okay on that? That's literally slope like Algebra 1 stuff, so we don't want to mess those things up. All right, let's see if we can get started on B. It says, using correct units, explain the meaning of the integral from 10 to 70 in terms of the rocket's flight. And then use a Midpoint Riemann sum with 3 subintervals. Okay, so let's talk about what this means. If I integrate velocity, and I'm not multiplying it by anything, if I integrate velocity, what do I get? Position. Okay, but this is an accumulation. It's an accumulation of the position between 10 and 70. So I'm getting the distance, the total distance traveled, or not the total distance traveled. I'm getting the displacement basically from 10 to 70. Does that make sense? That's what this is giving me, the distance that it has moved. All right. And then in terms of the rocket's flight, and then use the midpoint Riemann sums with 3 subintervals. Pay attention to this also, because this is something that we'll write the explanation tomorrow. But this is something that kind of hurt y'all on on a test that we did. We're not doing the whole thing. It's going from 10 to 70. So don't use everything just because it's there. And you need 3 subintervals. So we got to make sure we're reading that and we're doing 3 subintervals and that they are actually evenly spaced. Okay? Make sense with that? We good? Okay. Hang on to that stuff. We'll pick up here tomorrow. We'll re-talk about that one.